let's try to solve this problem. So let's draw our free body diagram really quick. It's going to look a lot like the little picture we have here. These are little pins. And of course we're going to have two reactions for each of these. It's going to be AX and AY and then CX. CY. And it looks like right here is another pin, which should, in theory, be BX with a BY. And we've got this evenly distributed weight, which we can represent as one weight, W. And let's see, W is 4.5 kilonewtons per meter times 4 meters. 4.5 times 4 is going to be 18 kilonewtons. So now that we have W, let's try to find anything else. So I think we can take the moment about one of these points now. We take the moment about A, then it actually gets rid of AX, AY. I believe CX and BY as well. I'll just say AX. That's a good philosophical question right there, isn't it? I almost want to say that we can also break these up into two different components. We can say that there is AB and BC. Again, with this sort of thing going on. Now, I believe if you have a moment about this point and anything crosses through it from any direction, then you can think of these as 0. So would BY then equal 0? Because it isn't twisting anything, so it must equal 0. So really we have figure 1 and 2 over here. So let's just worry about this one right here. So if we take the moments about A, okay, this equals 0, that equals 0. So we're going to have W, which is 18 kilonewtons. 18 times a distance of 2 meters. And let's see, if this is our point, we're going to be rotating with the clock, so this is going to be negative. And then we're going to have BX. It's going to be minus BX times 4. And that's all the forces. So then we can say, because of course this equals 0, but of course now we can say that this equals BX, and if we divide this by 4, then we can actually solve for BX. So if I do negative 18 times 2 all over 4, then get BX equals negative 9. And knowing that BX equals negative 9, we can actually do the sum of the forces in the x direction. So W is, let's see, 18 kilonewtons. BX is going to be negative 9 kilonewtons. So then AX, well, we can say this, plus AX equals 0. So we can substitute AX over and say this equals negative AX. So AX then equals, let's see, negative 9 also. Makes sense. Makes sense. So we've got we've got those two. I can write them right here. Bx equals ax equals -9. And then that's about right. So yeah, we've got ax done and bx also done, and I guess we already have w. So now we have ay and by. We also have this over here. How can we find ay and by? Whatever they are, they're going to equal each other and cancel out, I'm sure. Let's look at this over here. So we have bc, which is going to have whatever this was, it's going to be the opposite. So it's going to have 9 kilonewton this way. With by over here going up. And this is going to be whatever. Cx, cy. Alright. We know that Cx has to be the opposite of this. And that's +9. So Cx equals Vx equals Ax equals -9. We don't know anything about some of the forces in the y, though. If we take the moment about b, that also gets rid of ay. Boy, do they only want the x direction? I really hope so. They want ay. It looks like b is completely irrelevant. Well, we can find by actually by taking the moments about b, about c. I mean, take the moments about c. What are we gonna have? Well, we know that this is a right triangle with side 3, 4, 3, 4, 5. 3, 4, 5 special triangle. Cx and cy don't pass through. Bx and by, I mean, they do pass through. These don't. So these will cause two different moments. And this is going to be the moment, see, 9 kilonewtons. And this is going to be rotating it counterclockwise. So that's going to be positive. So it's going to be 9 kilonewtons times a distance of 4. Okay, there's the distance. Wait. It's up here, sorry. Distance of 4. This one's going to here be a distance of 3. This is going to be, let's see, rotating it. This is going to be minus by times 3 equals 0. Get out of here. So then this is equal to that. We can get rid of that, divide this by 3, and we get by is equal to 9 times 4 over 3, which equals 12. And if we do the sum of the forces here on this, then sum of the forces in the y, 12 minus ay, or no, 12 plus ay equals 0, so equals negative ay, so we can say that ay is negative 12. I think we should be good. -9. Wait. Yeah, -9. -12. And then Cx and Cy negative 9. What's CY? Ugh. Shoot. I forgot to find CY. Let's go back. Well, we can do some of the moments, some of the forces in the Y, can't we? We know BY. We know BY is equal to 12, so it must be 12 negative 12. So it must equal 12. Heck yeah. That's what it's all about.